So this is about integrals involving exponents of sine multiplied by exponent of cosine. Now we are going to look at the integrals which will involve the product of tangent. Okay, let me just write it down. Tangent and secant, yes. So let's say we have integrals of this form. Tangent is raised to some exponent, and so let me just write type 2 here. And here you will have exponent of secant will be always even. This is
Right.
So there is a different strategy for this type of integral when the exponent of secant will be even. And then in type 3 we will do an integral in which we will have both the exponents odd. Like tangent exponent will be odd, secant will be also odd. Okay.
Got it.
This is one type, and you can also do, with this strategy, you can also do integrals of this type. You have cotangent raised to some exponent and multiplied by cosecant raised to even exponent. Yeah. Okay. So what do we do here in this case? Actually, let me take an example. So basically what we will do is, in these type of problems, we will substitute our tangent. Let me change the color. We will always substitute tangent as u or whatever, u or t, and we will always separate out two factors of secant from the integral. Separate two factors of secant from the integral. Okay, you will understand this better when we do a problem.
All right.
Okay, let's do example number 3, where we have, let's say we have tangent square x multiplied by secant raised to power 4 dx. So our first step will be, we are gonna separate two factors of secant x.
Okay.
Okay, so let's put this tangent square as it is. Now this is secant to the power 4. I will write it as secant square x times secant square x dx. You will understand why I am doing this. You will understand it in the next step. Okay.
All right.
Now, as I said, we will use this substitution. Tangent of x, we will take it as u. So let's substitute tangent of x as u. So secant square x dx becomes du. This is why we have done this. Now this secant square x dx becomes du.
Right.
Okay, so whenever we have even power of secant x, we will always separate out two factors of secant, because that will combine with dx and it will become du. Okay, so now let's put all these values in the integral. So tan square x becomes u square, and this factor which is left, these two secants,
Right.
these you can write it as 1 plus tan square x. I hope you have heard of this rule. 1 plus,
Maybe, yeah.
yeah, this is the one that we are using. And in the next class, I'll tell you the proofs of all of these identities. Okay. And secant square x dx becomes du. Okay. Now this is simple. U square times, this becomes 1 plus u squared.
Plus u squared du. And then you substitute, you distribute u squared plus u to the fourth du. And then you would rewrite it 1/3 cubed plus 1/5 u to the fifth plus c. And then you resubstitute u back in with tan x.
Yep. U 5/5 plus c. So what was u? Tan, right? So this
Tan.
becomes tangent cube over 3 plus tangent 5
Tangent at 5 to the 5 and plus c.
plus c.
Yay.
Okay.